Let's begin. Today is June 11th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So today we have an all-odd lineup of criteria card 1, 11, 15, 17, and 19, and they all use the orange verification cards. The code above is your way to get more information and details on today's puzzle on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we got criteria card A, criteria card B, and criteria card C. And on the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at the first digit, the triangle digit, and basically compares it to either 1 or anything greater than 1. So the Turing machine will let us know whether, again, is it 1 or anything greater than 1. Criteria card B looks at the first 2 digits, the triangle and square, and compares them. So should the triangle value be less than square? Should they be equal? Or should triangle be larger than square? Criteria card C will look at the 3 digits in our code and will let us know which one is the absolute largest. Could it be triangle? Could it be square? Or perhaps even circle? Criteria card D again looks at the 3 digits in our code and will let us know how many of those are even. Are there no evens? Is there a single even? Perhaps 2? Maybe even all 3 are even. And finally, criteria card E will again take a look at the first 2 digits and add them up and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should it be greater than 6? And remember, the objective of the puzzle is to find this unique 3-digit code that abides by all the criteria that we've described. And we're going to start off with our first proposal of 314. So what's the first thing we want to test? I think I want to find out how many evens there are in our final solution. So I'm going to test criteria card D. Okay, so the Turing machine approves of my proposal. So again, if we look at our the initial proposal of 314, I've got 2 odds to 1 even, and the Turing machine approves of that. So in essence, yes, our solution has only 1 even. So that's what I'm going to write down in my notes. So there is only 1 even digit. Okay, now we don't know which one it is, but at least we know we've got 2 odds and 1 even. Okay, so, well, that said, well, let's see. I was going to say something about the sum. I guess you can still have a value of 6 when you have 2 odd values. You could have a double 3, 3, or some combination of 1, 5. And I am also noticing if you look at the 5 criteria cards, I guess technically only criteria card C has anything to do, directly at least, with circle. Everything else is either triangle or square. So I'm wondering if it is a 6, it has to be the 2 odds, and then it would force circle. But if it's a 1, 5, then how would you figure out what circle is, meaning implying it'd be even? So I'm wondering if indeed maybe the top is going to be an odd even combination and the sum is not going to be 6, which means that this may be a good proposal to try, or sorry, good criteria to test criteria card E. So let's go ahead and test E. Okay, so it also approves of the proposal. So again, criteria card E takes the sum of the first 2 digits. So I've got 3 and 1, that adds up to 4. So what the Turing machine is telling me is that the sum has to be a sum that's less than 6. So let me go ahead and write that in the notes in section E. That triangle plus square has to be less than 6. Okay, so what that means is that neither triangle nor square can be 5s, because 5 plus anything, even a 1, would be 6 or greater. So we know that triangle and square have to be any any digit, or digit between 1 and 4. Okay, anything else? So somehow we're ordering, criteria card B is ordering the first 2 digits. And we do have, could be equal, it could be both 3. So we know it can't be 4, 4, because that's already greater. Oh, okay, well, yeah, never mind. We are dealing with a sum that's less than 6. So we could add up 1, 1, 2, 2, but not 3, 3, or 4, 4. And it can't be 2, 2, because we only have 1 even. So if it's 1, 1, well, sure, circle's going to be greater, but which one is it? Is it 2 or 4? So I think that sort of proves that it can't be equal. It's got to be some order, and maybe that would be a good opportunity to test whether the ordering is correct. Let's see. Yeah, I think that may be our best option, even though it's a 50-50, but it would be almost ideal to know that going forward. Okay. Yeah, let's go ahead and test criteria card B. Okay, so it does not approve of the proposal, and again, I've got triangle as 3, square is 1. So in my proposal, my triangle is greater than square. Again, I'm pretty confident that it's not going to be equal. It can't be equal. Yeah, I don't see anything where they could be equal. So that means I'm going to deduce that, in fact, triangle should be less than square. And so that was B. So I'm going to write down, I'm going to deduce that triangle is less than circle. I'm sorry, triangle is less than square. Okay, and since we are adding the values, I think we have opportunity to cancel some numbers. So triangle can't be 4, right? Because if it's less than square, what would it be? So it can't be 4. And square can't be 1, because again, what would triangle be if square is 1? Okay. What else? Can triangle, and I think triangle can't be 3, because again, if it's less than, it would add up, it would could only be paired up with 4, and that sum is greater. So yeah, so triangle can't be 3 either. Interesting. Can we go a step further? If it's a 2, it would add to 3, but not 4. And then 1 could be added to any of them. Let's see. Yeah, I think that's it. Yeah, it'd be 2, 3, and then 1 in all the others. Okay, so I think that does it for any cancellations based on criteria card B and E. So let's go to our phase of sort of strategizing and constructing a good, viable second round proposal. All right, so let's see. So again, we have only one even. So if the triangle were to be even, it would have to be 2, 3. That would be the only combination that would work. And then at that point, either circle or square would be the largest. You could say that it could be 2, 3, 5 or 2, 3, 1. It couldn't be 2, 3, 3 because then there wouldn't be an absolute largest. And then what about so let's actually do this. Let's start listing some of these out because I think there may be some opportunity to eliminate some possible choices. So again, let's pretend that triangle is 2. That's our even. Since we need to have a sum that's less than 6, the only thing it could be paired up with is 3. And then it could either be a 1 or a 5. Again, we have really nothing to tell us what circle is. Perhaps it might be the largest, although in this case, square is the largest. So we got 2, 3, 5, and I believe those are the only possible solutions where the triangle's even. So yeah, 2, 3, 1 or 5. Okay, let's move on to 1, and 1 does have a lot of possibilities. So let's first take the case where square is even. So we have 1, 2. It could be 1, 2, 1. There's nothing, I don't see anything where that could be wrong because square would be the largest. 1, 2, 1. Yeah, 1, 2, 1 works. Okay. So hopefully our list doesn't get too large. And now, could it be 1, 2, and then circle would have to be another odd? I don't think that's possible because, again, how do you differentiate between 1, 2, 3 and 1, 2, 5? Circle is the largest in both cases, and they're both odd. So I don't think it could be 1, 2, and then 3 or 5. Because I don't see a way where I could differentiate between those two. So I think that's it for 1, 2. If it's 1, 3, oops. If it's 1, 3, it could be a 2 because you could say square is the largest, or it could be 1, 3, 4, where circle is the largest. So I could see both cases, 1, 3, 2 and 1, 3, 4. Okay, that's 1, 3. Okay, now 1, 4. Well, there's our even, so now we need an odd. In that case, I could see, I think all of them, 1, 4, 1, 1, 4, 3, and then 1, 4, 5. Yeah, wow. So the list did get a little bit longer than I had hoped. 1, 4, 3, and 1, 4, 5. Let's see. Okay, so this list, can we make any sort of conclusions? Can we eliminate some possibilities? let's see, so in this case, I guess anything that ends in a 5, which are few, are where circle is the largest. And so if circle is the largest, okay, so the other thing that would differentiate is obviously criteria card A. That would be huge. If I could eliminate it from being 1, then that would leave these two to pick from. And that would be huge. So let's see. The only other thing that we have not tested is which one's the largest. So I think it may be safe to say that obviously triangle is not the largest, right? So here it's 2, so definitely it's not the largest. So it's definitely between square and circle. And what else? So we've got square or circle to be the largest, and then either we have a 1 or we don't for triangle. And so if it is not 1, then yeah, it would come down to either being square or circle for these two. And that would be huge. Let's see, what if we don't test that and only test the largest? What would it eliminate? So again, here this is square, this is circle, square, square, circle, square, square, circle. So it's almost half and half. So I wonder, yeah, so let's say, what if it is a 1? And again, the only other thing that could eliminate is criteria card C. So if it's a 1, we have all of these to pick from. And so, yeah, I don't think it can be 1 for triangle, because I think you have too many possibilities. Because again, here it's square is largest, square is largest, circle is largest, square is largest, square is largest, circle. So the fact that, it's not one or the other leads me to believe then that it must be greater than 1. And so then really I only have to test which one is largest, square or circle. So it's between 231 and 235. So this is very interesting if it comes out to be true. So let me go ahead and test, I'll say 235. Let me go ahead and test 235. Let's see, is there an advantage to picking square or circle? No. Let me do this really quick just so that I can take a look. I'm going to label each one with a C or an S to tell me which was largest. So here square is largest, the middle one. Here circle is largest. Here again square is. So is this one. This is circle is largest. Here square is, square, and then circle. Okay, so 1, 2, 3, 4, 5 squares to 3 circles. Again, if it were a 1, there's not enough information to cancel, or to pick just the 1. So that's why I'm saying that I'm deducing that the triangle is going to be greater than 1, and then it's going to be one of those. So yeah, so let's go ahead and let's just test. I'm going to test where circle is the largest. So I'm going to test 235. Okay, and again, all I'm going to test for right now is C, criteria card C, to find out which is the largest. Okay, so the Turing machine does approve that the circle should be the largest. So let me write that down in my notes for section C. So I will say that circle is the largest. And I'll just spell it out. Okay, so if circle's the largest, then I can cross out everything where square is. So I'll cross that out. Cross this one out. As well as this one. Oops. And this one. And this one. Okay, so I'm left with 2, 3, 5, 1, 3, 4, and 1, 4, 5. Okay, so let's see. And so let's go ahead and since circle's the largest, we know circle can't be a 1. And that may be it. Okay, so let's see. Let's go ahead again and inspect everything that where circle is the largest and see. Because again, I'm saying 2, 3, 5 is correct. So of these, how are 1, 3, 4, and 1, 4, 5 ambiguous? Because that's what I was basically concluding. Oh, that they both have a 1. So if they both have a 1, yes. 1 is less than 3, 1 is less than 4, yes. Circle's the largest. They both have 1 even. And there's some, yeah. So that's why you can then cross out 1, 3, 4, and 1, 4, 5, because, you know, the thought is that if the triangle is a 1, then you can't distinguish them. So yeah, so we can cross those out. Those are essentially, you cannot distinguish them. Okay, so then yeah, I will say that the solution should be 2, 3, 5. So let me type that up. 2, 3, 5. My computer's lagging a little bit, but there we go. All right, so 2, 3, 5. Let's go to turingmachine.info and verify. All right, let's test 2, 3, 5. Let's verify. Fantastic. And because we tested less than the number of criteria, I'm very confident that we did beat the Turing machine. But let's verify. All right, so we tested B, D, E, and then C in the second turn. So B, D, E. And we had one more round where we only tested C. A, we deduced that it had to be something greater than 1. So let's see, how do we do? Okay, so yeah, we did do it both in 2 rounds, but obviously we did ask 2 fewer questions. So what a great puzzle. So as you can see, you know, it was very helpful, strategy 1, to list potential solutions. And then in many cases, I can't say for all puzzles, it's also a good idea, this concept of almost thinking through and identifying potential solutions where they meet all the criteria, right? So all these 1s basically met the same criteria. That triangle is 1, but and in this case, there were multiple cases where there were squares as the largest and circle as the largest. So even though we had even these 2 conditions, there was no way we could pinpoint it down to a single value that met these kind of criteria. And so it once you kind of identify a group of potential solutions where you can't differentiate them based on, sort of, I hate to say it, but assumptions. But because they're clumped together, you can't really eliminate them, uh, meaning you can't reduce it down to a single solution. So they're ambiguous. And so once that's, I think, a very powerful strategy. Obviously, it is time consuming and you do have to be careful, of course. But in this case, it really made it so that we didn't have to test one of the criteria cards. Not to say that it wasn't important either, but it was important because it helped us eliminate a lot of choices. And so just a couple of things to keep in mind when you're solving puzzles, at least Turing machine puzzles. Those are some great go-to strategies. Listing out all the potential solutions and seeing if you can identify ambiguous. Well, that's it for today. If you have any comments, please do share them. And if you like the video, give it a thumbs up. If you don't want to miss out on any future videos, please subscribe to be notified. Well, until next time, have a great one.